Number 12, find the exact value of cosine 15 degrees and sine 5 pi over 12. Now, one thing we could do is you go over the calculator and just type in these values, but there's going to be a problem when you look at your answer because the answer choices on the actual test are not going to be like decimals. And right now, if I typed in cosine of 15 degrees, you'll see that the value it gives me is just some random decimal value, 0.96592, so on and so forth. Now, that's not going to be an answer choice. So how do we find these? Well, we learned an identity called the sum and difference. Let me pull that up. Here, we have the sum and difference identities, and they were listed here. It says that if you have a cosine, you can use two different angles, either adding or subtracting. To give you 15 degrees, you could substitute in this to solve for the problem. So that's what I'm going to do here. I'm going to say that 15 degrees, I'm going to use 45 minus 30. So I'm going to use this formula here. I'm going to use a cosine difference formula. So let me come back over here. I'm going to say that cosine of 15 degrees is the same thing as cosine of 45 minus 30 degrees. Now, you don't have to choose those two. You could use 60 minus 45 or anything else, but I just choose angles that are on your hand for the hand trick. So the difference formula for cosine says that this is angle A, this is angle B. It says that cosine of angle A times cosine of angle B, and then it'll be plus, because cosine's formula changes. It starts as a minus, it's going to become a plus, of sine A, sine B. So now I'm going to use a hand trick. 45 degrees is the middle finger, so I'm going to take my middle finger, I'll bend it, flip it, and I have two fingers on top, two fingers below. The x's come below because it's y over x. So this would be square root of 2 over our h, which is square root of 4, which will in turn turn into 2. And while we're on 45 degrees, I'll go over and do sine. I had two fingers above, so this is also square root of 2 over 2. Now I'm going to do the 30-degree angle. Looking at my hand, 30 degrees would be represented by the ring finger. So when I take my ring finger and I bend it, I flip my hand over. I have one finger on top, three on bottom. Cosine's x, which is fingers on bottom. So I'm going to say this is square root of 3 over 2, and the sine would be square root of 1 over 2. When I go to simplify, these are multiplications, this is addition. Square root of 2 times square root of 3 is square root of 6 over 4 plus, this would be square root 2 over 4. And since I have a common denominator, I can rewrite that as square root 6 plus square root 2 all over 4. That's my first answer. Now I'll go check this in the calculator. We have square root 6. Again, square root 6 plus the square root of 2 all over 4. And my hope is, yep, these are exactly the same, so we did it correctly. So now let's try sine of 5 pi over 12. I'm going to move this off to the side a little bit, if it'll let me. It doesn't look like it's moving. Let me try one more time. Oh, there it goes. All right, I'm going to move these off to the side. And now let's try sine of 5 pi over 12. Now, when it's in radians, our key is going to be this. We're going to choose two values of pi over 12 that will reduce. So what am I saying? If I chose 4 pi over 12 plus 1 pi over 12, this one would not reduce. That would be a bad value. It would not work for me. So I'm going to choose two values that add up to 5 that will both reduce. 2 will reduce and 3 would reduce. So I'm going to choose 2 and 3. So this would be a sum of sines formula. So I'll go over to my formula chart and I look at sine. With the sum of sines, I realize the symbol will stay the same. This will be sine A cos B, cos A, sine B. So let's plug this in. This would give us the value of sine. Now this first one will reduce, and this becomes pi over 6. This one's going to become pi over 4 when I reduce. So let me write that right there. So we'll have sine of pi over 6 times the cosine of pi over 4 plus, since sine's symbol stays the same, cosine of pi over 6 times sine of pi over 4. I'm going to use my hand trick. Pi over 6 finger is your ring finger, so I take my ring finger, bend it, and I flip it. Sine has one finger up, so it'll be square root of 1 over 2. Now I'm going to go to the cosine. I have 3 cosine fingers, so it'll be square root of 3 over 2. Now I do the pi over 4, which is our middle finger. Take it, bend it, flip it. Cosine is the fingers on the bottom, so this would be square root of 2 over 2, and sine would be the fingers on top, which is also 2 over 2. When I go to simplify this, I get square root of 2 over 4 plus square root of 6 over 4, which again we could reduce, and it's the same exact answer as the previous. I know they switched the order, but that really doesn't matter. This would be our value. Let's check it out in the calculator. We're going to type in sine of 5 pi over 12. So I go trig, sine, and I'm going to type in 5 pi over 12. And the key here is you have to tell the calculator what mode you're in. If I just type it in like this and press enter, this will probably give me the wrong answer because my calculator is in degrees. So what I'm going to actually do is type this in and press R for radians. And sure enough, I got the exact same value that I had previously with the same square root that we just got. So we did do it correctly. Notice without the radians, though, the calculator gives me the wrong answer.